integration by parts is another method of integration, and it uses this formula here. And this is a strategy we'll use. It's basically a tool that we have when we get stuck. So we want to first start with identifying something as a basic integral. Okay, in this case here, x cos x is not a basic integral because although x and cos x individually are, together they are not basic integrals. There's no algebraic rearrangement. And then if I try substitution, and I should try substitution first, there's no substitution that will let me get rid of an outside function. So I'm stuck. So what I can then do is I can try using integration by parts. Okay, integration by parts works by choosing a u and a dv, breaking it up into a u and dv part, where I choose the most difficult dv which I'm able to integrate. Okay, the most complicated expression that I can integrate. And if I can do that, often the new integral that I come up with, okay, so this is my starting integral here. I'm going to generate a new equivalent integral that is in a different form. And we're hoping that this new integral in green is easier than what we started with. So this is how integration by parts work. We need to split this up into a u part and a dv part. And the dv part's going to include the dx part. So what we want to do is choose the dv part that's the most complicated part of this that I can integrate. So if I group that together, I can still integrate that. Okay, so I'm going to let my dv be cos x dx. And from that, I can generate my parts. So I'm going to integrate that. So the integral of cos x is sine x. Okay, and that means that the other part here, the x part, is going to be my u part. And from there, I generate a du part. So du just ends up being dx. Okay, so I've broken it up into parts. The key is to choose a dv that's the most complicated part of that I can integrate. And then I see what happens. So I'm just going to see what kind of integral I end up with. So I'm starting with my u times dv. Okay, so this is what my starting point is. And I'm going to generate a new integral based on this formula. So it's going to be u times v, so x times sine x, minus, and this is a key part of this. This is what I'm looking for. The new integral is going to be v. So in this case, v is sine x. Okay, so my v is sine x. And then the du, well, the du is just a dx. There's my new integral. And I have to evaluate this new integral. Is this easier than what I started with? Well, yeah, because this new one, doesn't have that extra x in there. We can find an antiderivative for that. So then this equivalent expression, I'm going to anti-differentiate the equivalent expression instead of the one in yellow, and to get the answer for that antiderivative. So the antiderivative of x cos x is going to be x sine x minus the integral of sine is going to be negative cos. And then don't forget the plus c, since it's an indefinite integral. I'm going to simplify this into plus cos x. And then plus c. Again, don't forget your plus c's.